Okay. Is it now working? In Bangalore, without AC, it is colder. Sorry, with AC, it is, yeah. Without AC, it is colder than with AC. So sometimes you don't realize the difference between when AC is on or off. And from that AC output duct, you actually get cold air. Okay, so we'll first go through the next. This is not assignment three. This is last year's assignment two. This year is assignment two. So, how do we optimally refill ATMs? So you have seen those trucks, no, not trucks, but vans which carry cash from and deliver to the ATMs, refill the ATMs. So the idea, the problem we'll try to solve in this assignment is how, given a certain demand of cash in different ATMs in the city, and given that we have a certain fleet of vehicles, how do we decide the vehicle ATM assignment on a particular day? So which vehicle will be going to which ATM on a particular day? One thing to note is this is not a vehicle routing problem, so we'll not be deciding the route of ATMs. I mean route of sorry, route of a vehicle. So we will just decide, we'll just do the vehicle and at ATM assignment, and we'll be assuming that the distance between each ATM is constant, because with a vehicle will deliver only within a certain area, and the distance between each ATM will be 30 minutes. So that is an assumption. So now coming to the problem. Okay. So we can have different vehicles of different capacities and different costs, and yeah, and these are all the constraints and objectives. So at the end of the after we go through the slide, we'll try to figure out which are the objectives, which are the constraints, and it is immaterial. And actually, these are constraints, objectives, and as well as assumptions. It is immaterial at what time of the day a vehicle is refilling a particular machine, meaning you will have a particular ATM will have a certain demand or requirement of cash on a particular day, and at what time, let's say it is 2 lakh rupees, and at what time you are delivering in the day, that doesn't matter. So we just started a minute back. So this is the next assignment. So the next assignment is we'll decide how to allocate ATMs. Sorry, how to allocate. So you have seen those vehicles which carry cash to refill the ATMs. How do we decide the vehicle ATM assignment? So which vehicle should be visiting which ATM on a particular day? And we'll not be doing a vehicle routing. This is not a vehicle routing problem. So we will be just doing the vehicle ATM assignment. So which vehicle will be an ATM on a particular day, but what sequence of ATMs what will be the sequence of ATMs, that we will not be deciding. So it's a singular problem, and so yeah, we just went the first two objective assumptions. You can read that. So that there are different vehicles of different capacities and different costs, and depending on the cash we need to carry, we will be assigning the vehicle. Obviously, the vehicles with higher capacities will have higher costs, and in any day on a particular day, you will have a certain demand of cash. So how the demand is would be calculated is, this is again like the inventory balance constraint we were doing earlier. So let's say at the end of the day, you know how much cash an ATM has. Let's say it is 1 lakh, and every day you want to maintain. So a constant, an ATM will have a constant demand. That ATM has a constant demand of a requirement of 5 lakhs of cash every day. And if at the end of at the beginning of a day, if you have 1 lakh cash, then next day you need to deliver 4 lakhs of cash. So the remaining amount. And at what time of the day you deliver that 4 lakh cash, that doesn't matter. So it might happen that this is the first ATM which the vehicle goes to use. It might happen it's the last ATM the vehicle goes to, that doesn't matter. As long as you do at any time of the day, it is fine. And for security reasons, obviously the requirement will be higher for ATMs with higher footfall. For example, in malls or where there is more, there is more consumption, there will be more demand of cash. And the third point is the ATMs. For security reasons, the ATMs visited by the vehicle should be as different as possible, meaning uh, like in vehicle routing, we discussed that ideally a driver should be visiting the same, the same apartments or same places every day. But in the case of cash delivery, it is opposite way because we do not want the driver to be too familiar with the ATM setup. So we want, there should be as much diversity. Even if a vehicle is visiting an ATM today, it should not visit the next. It should not visit the same ATM before today plus X day. So the X is something you can. It's configurable, like you have the minimum gap, maximum gap, and the assignment. Even if that results in lower cost. And of course, you will have a limit on the maximum cash that you can carry, that the vehicle can carry. Uh,
So,
okay.
what does that mean? Even if that results in lower cost?
Oh, that means that let's say, but we are actually assuming that no, I mean that would have probably made sense if it was a vehicle routing problem, but here we're assuming that all the ATMs are equidistant, so probably that results in, even if that results in lower cost, does not make sense. But what I was essentially trying to say by that is, let's say uh, these are your ATMs, I mean, and the distance between each ATM is the gap between each ATM is the distance. So let's say an ATM, a vehicle has already gone to this ATM yesterday, this one, and this is day one. It has gone to this. It has gone to some ATM, but it has also gone to this one. And day two, we are assigning this ATM, right? So technically, since this ATM is very close, we should also assign this ATM. That makes more sense, but because that will result in lower cost. But we will not do that because it has already gone to that as ATM the day before. That is the reason. But again, in this case, since we're assuming that all the ATMs are equidistant, it doesn't matter. Maximum cash. So
So we could have done that for like in day one only we would have asked him to visit both of the ATMs. And from day two we should not assign these two but the other ATMs.
Yes, yes, we could have done that. But again, in this problem, we are assuming that all the ATMs are equidistant, so we are not solving that vehicle model. But yeah, what you're saying is true that in this case we should have ideally assigned. But it might be that these two ATMs have a very high limit, very high cash requirement. So one vehicle cannot supply cash to both the ATMs. That is possible. And again, but the next day the requirement might have reduced.
And by the way, when you say equidistant ATMs, you don't in a line. So shouldn't it be on a
No, it's not
like
a
a polygon?
yeah, it should not be in the line, but yeah. But okay, it can be in the line also, right? In the same, let's say your OMR, you have these ATMs, right?
They are equidistant just with respect to the previous and the next one. For instance, distance between 2 and 3 is not
Yeah,
same.
yeah. So when I say equidistant now in your actual assignment, yeah, they'll be maybe in a, yeah, it's like they're in a polygon. I mean, it's not a circle, it's not a polygon, but they are equidistant. That's all of them are
ING are
equidistant. Yes.
equidistant.
And okay, and one more problem, one more concept I did not explain in vehicle routing is, so we have something called subtour in vehicle routing. So subtour is basically if you have certain, did I explain about subtour? So if you have certain, let's say these are your nodes, right? So your depot is here, this is your depot. So if you go like this, and then you return back to the depot basically. So you go like this, and then you go to here, right? So basically, you are doing two tours, right? So you're coming back to the depot. So this is called sub tour. So when you're having two tours, but if you do everything in one trip, then that is it's called a sub without sub tour. So yeah, minimize inventory holding costs, minimize the cash that can be stored in an ATM. Okay, so one more point is if the cash requirement of an ATM has to be fulfilled by only one vehicle. So if the cash requirement is very high, we cannot have two vehicles visiting the or two or more than two vehicles visiting the ATM, because again that is for security reasons, because we don't want too many vehicles on a particular day. On a particular day, there should not be more than one vehicle. It should be satisfied only by one vehicle. So the assumption is there will be, the cash requirement of an ATM will be less than the capacity of at least one capacity of the vehicle. And the other requirement is if whatever cash requirement, sorry, whatever cash a vehicle is carrying, that should not come back. I mean, it should not come back to the. So it will obviously pick up the cash from one bank, from the bank's vault, and it will not come back to the bank with some cash. Meaning, even if that means we need to keep some extra cash at an ATM, that is fine, but it will not return back with cash. I think that is there somewhere else. And minimize inventory holding costs. So we should,
What do you mean by it should not come back with cash?
meaning
Because
let's.
suppose an ATM is
No, of course, sorry, that's not valid, because obviously it will accordingly carry the cash. It will not happen. Meaning, let's say if a vehicle is going to this ATM and this ATM, and here I need to put 2 lakhs and here I need to put 3 lakhs, then it will obviously carry 5 lakhs of cash. But, minimize the cash. Yeah. So and how much cash we need to refill at an ATM? That is obviously that will come. How do you get that? How much cash an ATM is carrying should have?
how much cash an ATM should have.
How do you know that?
You can ask the information to the ATM how much cash, how much the
Ask
capacity is, and
Yeah, of course, if you cannot carry more than the capacity, but
no, so the ATM must have a system which we will be communicating.
no, but how do you know how much cash people will withdraw from an ATM on a particular day? Accordingly, you need to put cash.
More popular areas, we need more.
Yeah.
There are more demand.
Fast demands.
So what technology you use to find that? Can use ML, right? Can use some
Predictive analytics.
right, find out that. So again, this is an area where you can merge ML and OR. So that forecast that we get, that obviously will be refilling. That is again like your the inventory we were discussing earlier. We should not have too much inventory or too less inventory. Similarly, we should not be having too much cash or too less cash. We should be just containing. We should be just having. But again, that comes from your predictive model. So we should. We should not be having too much cash because in an ATM, because for security reasons, and then we do not want the money to lie idle, right? And then there would be a limit on the minimum and maximum cash that an ATM must have. Um, Meaning, okay, minimum is an ATM can have access, as we discussed. So what are the objectives of this problem? We want to obviously fulfill the demand of each ATM. We want to we want to do that with minimum number of vehicles that we have. So even if I have 100, even if the bank has let's say 30 vehicles, 30 vehicles is hiring from the logistics company, but if it can do if we can do with 20 vehicles, we will use only 20 vehicles. So we want to minimize the number of vehicles used, and we want to balance the workload across vehicles, both in terms of number of ATMs visited and the cash deposited. So it should not happen that one vehicle is carrying 10 lakhs and the vehicle is carrying 1 lakh, or one vehicle and
By the way,
also
where is the bank located in this picture?
no, in this picture.
In this one, so
The bank can be located probably somewhere in the center. I mean, that's not
Is
important.
there only one bank? Or there are more banks.
Yeah, I mean, you can imagine that these vehicles are working only for one bank, and
For instance, one vehicle can go to only one ATM on a particular day.
No, no, it can go to multiple ATMs. One vehicle can go to multiple ATMs. One ATM cannot be visited by multiple ATMs.
Right. So, like for example, if there are two banks, then the
No, you can imagine that the bank from where it picks up the cash is only one. So at the beginning of the day, it will pick up cash from one bank.
Can
I mean,
it
whatever.
visit the same bank twice or not?
Hmm?
Can it visit the banks twice? Or
No, no, no. Yeah, so probably that's not mentioned. Yes, it's not mentioned here. But yeah, we have to assume that there is no surplus, so it can visit only once. So it will visit at the beginning of the
not?
day. Yeah.
Fixed.
And then it will go to all the ATMs and yeah. Yeah. So workload balance across vehicles and then denomination constraint. Then because you have different kinds of notes, so based on the denominations which the ATM can handle or require, the vehicle must refill accordingly. And also there will be a certain demand of notes, requirement of denomination. So we should be carrying the notes accordingly. Um, and again, can put a constraint here that I mean, I've not written it here that sometimes you have seen that banks, the ATM will give you only 500 rupees, not although you have 100 rupees. So you can add an objective here that uh, satisfying the total demand is more important than satisfying the denomination demand. Meaning the vehicles and the ATM will have limited capacity. So the satisfying the demand of let's say whatever 10 lakhs you have, that is more important than satisfying the demand for each individual denomination. Cash requirement of every yeah.
Sir, could you repeat that again? What you just said?
Yeah. So what I meant is, let's say I have an ATM which has a requirement of 10 lakhs, right? And I have out of that 9 lakhs should be in 500 denomination and 1 lakh should be let's say 200 denomination. But let's say now there are two. Okay. Now let's say the vehicle which goes to this bank has has a certain capacity also, both in terms of the cash it can carry, capacity on the registration, and in terms of the denomination it can carry. So let's say it can. There is a denominator. I mean, there is a rule that it cannot carry more than 600 currency notes, for example. So that means you cannot. It cannot carry 700 currency notes. So you have 700. So it will override. So it will not give this. It will not satisfy this denomination requirement. It will give everything in 500 denomination. But that requirement is also that objective is also there, but it's a secondary requirement. Cash. Yeah, and we should be meeting the cash requirement of every ATM, even if that means that requires hiring vehicles on rent. So that means if your available vehicle is let's say 30, and let's say during Diwali you need more, people withdraw more money, so you need more vehicles. The model must tell. I mean, model must not. It should not happen that the model is using only 30 vehicles and meeting 80% of the demand. Then model must tell me that I should be using 35 vehicles on that day. Model should tell me that. Um, so this is I think kind of what we were discussing yesterday, that if you have less headcount capacity, then the model should tell me how much extra headcount I should. Okay, and you can assume that every ATM refill requires 30 minutes. That includes the travel time from the previous ATM to the current ATM and the driver's lunchtime breaks, etc. So that means if number of working hours in a day is 10, ATM can visit, the vehicle can visit 20 ATMs in a day. So it can at max visit 20 ATMs, but it can visit less than that also. But again, it should not happen that a vehicle is going to only 3 ATMs in a day. That will again contradict with this one. Maximum number of ATMs that a vehicle can visit. Okay, so this is actually this one. I'll remove this point. Yeah, this is this one we discussed. And when a vehicle is, so we'll assume that the requirement of every this one I don't remember, but I think this one you can ignore because if you have 1 lakh requirement and if I think this one you can ignore. So these are your constraints. This is the overall problem. So what are the objectives? Objectives are minimizing number of vehicles used. This one is one objective. This one is one objective, and the denomination objective we just discussed, that is another objective. and meeting the meeting the cash requirement of every ATM, that is hard constraint here. So that is, it's not a soft constraint. So that's a hard constraint, and the time number of maximum number of ATMs vehicle can visit in a day is 20. That is a hard constraint. The capacity of every ATM, capacity of every vehicle, that is a hard constraint. Yeah, and vehicle and an ATM can take money from only one vehicle in a day. That is a hard constraint. And then the ATMs visited by a vehicle should be as different as possible, and then that is a soft constraint. So you can. So what should be the planning horizon for this model? What do you think should be the planning horizon for this model? I get a planning horizon. I think I told you, but maybe not explicitly. So it depends. It is basically the period for which you are running the model. It can be 1 hour, one shift, 1 day, one quarter. Not just for this model, the final model.
We should run it on daily basis.
Hmm?
Daily basis.
Okay, so how many days? I mean, what do you think? How many days?
For every day.
Every day.
Yeah, it should be for every day. That is true. But if you're doing it for every day, then you need to, yeah, then you need to take into account the third bullet point. That is, you should be considering that in your constraints analysis. So you should be looking at historical allocations, and you should be accordingly setting higher priorities for assignments, where you are assigning an ATM different from what was assigned in the last 3-4 days. So you should be setting higher priorities for those assignments. Okay.
So what is meant by equidistant ATMs?
Equidistant?
Equidistant ATMs. I didn't get it. For example, if there is a square.
Yeah, I mean, it's not it cannot be exactly equidistant. Yeah, I mean, let's say.
In a planar diagram, you can't have this.
Yeah, I mean, let's say
After three vertices,
you have a octagon or hexagon, right?
just take a square. I mean,
Okay, square.
Yeah.
So square, then let's say your bank is here.
Mhm.
So then in that case, it can go to 4 ATMs. I mean, you can ignore the first trip before from your bank. After that, all the 4.
But like suppose this is 1, 2, 3, 4.
Hmm.
Then 1 and 2, 2 and 3 are equidistant. 1 and 3 are not equidistant.
No, then it will go to. We'll assume that it will go to this.
So we are considering the path which the vehicle follows is of equidistance ATMs.
Hmm.
Then it is as good as a line.
Yeah, and again, these are some assumptions we need to make sometimes, because again, see, there will be other things like although the distance, you might say that although the distance are equal, there might be more traffic here, so it will take more time, right? But again, in assuming that all those, and just for simplicity of the problems, we're assuming that they are all equal. Ideally, this should be combined with vehicle routing, but just to keep the problem simple, I've done it this way. And also, there will be other things which will make it ununiform, like the driver will take lunch break, or should take, so those things also need to be baked in. So what will be the output of this model?
Would be the route of a particular vehicle for a particular day.
No, not route. So
Not
that,
route.
route that
It would
cannot
be
be.
the vehicle, it would be the ATM, and it would be the time of the day.
The time I said doesn't matter. Then we again going back to vehicle routing. You can fulfill at any time of the day.
No, but how would you know at which time does my vehicle visit?
You don't need to know that. So the vehicles, that's why I made the
Oh, yeah, I
equidistant.
don't need to know.
So it will be just vehicle and vehicle ATM assignment on that day. And
Vehicle ATM and day. That's
okay, yeah. So now there's an interesting question. So let's say you said we want to run the model for each for one day. So today you want to run for tomorrow, whatever. Today beginning of the day, whatever. But let's say today is Saturday. So today I want to run for the next 5 days. I want to run this model for the next 5 days, right? That is Sunday to next Saturday, next 7 days. Okay, let's say next Saturday, next 7 days.
Why would I run it for next 7 days? You run it for just one day. I would run it in the morning. Something like that.
No, sometimes what happens is they want to have some like operations people. I mean, the operations in the sense the vehicle companies might want to get might want to know this prior to the not the day before, right? And of course, if there is some change in the input data, you need to refresh the model, but then you get some high level idea. So if you are running the model for the next 7 days, do you need to run one single model for? I mean, we were discussing yesterday about one model and multiple models. So do we need to run one model for the 7 days, or can we run 7 separate models for the 7 days?
I mean, we have a lot of time, so we can run one.
No, no, that not, a lot of time is not the point. But again, if it might that might also take a lot of time. It might take 4 hours.
So what we want
But
until the next day you are
I mean,
not
just
going
imagine
anywhere.
you are the vehicle, you are in this company which, and again, there are some companies which offer, which build this kind of model. So you don't want to wait for 4 hours sitting in front of the computer waiting for it to give them.
Why would I wait for 4 hours? I would just give the input.
No, sometimes you need to take some additional, you need to decide some additional things based on the output of the model. So, and again, these days everyone wants everything fast. I mean, it's not just about, okay, so I can wait, so I'll wait. But everyone wants, even the users want.
If I can get 7 days data for 4 hours, then it's good trade.
Okay, but okay, suppose let's say, yeah, you can do that for sure, but do you really need to do that, or can you run separate models for 7 days?
We can run separate models. No.
You can run separate, or you cannot run. Huh?
Like if we run repeated several models, then will they have information about other models, like other days? Because we don't want vehicle to go to same ADMs on the replace, right? So they should have this information.
That you can also, that is there. Okay, that's a good point. Apart from that, yeah, but let's say that is not that high priority, so you can run for day one, and then day two you can set a, you can configure your model that you want to give lower priority to the to assignments which have already happened in the past. Meaning, if a vehicle has registered an ATM past day one, then you want to consider a priority. Those things you can do, and that is, let's say, lower priority. So apart from that, anything else, why you can use a separate model or cannot use separate models for separate.
As you said yesterday, that running separate model will be fast.
No, but why you can, faster is one point. I mean, you're talking about performance, but is it correct to run separate models in this case?
So after each day, there will be some amount of money left in the ATM, right? Like you need to account for that also. Like tomorrow, if you need to refill tomorrow, you need to account like what money is like left in the.
That is there. Yes. Yeah, that's there. That's I will realize. Yeah, I was thinking. I mean, the answer I was looking for is there is no interdependence between days between the different days. But yeah, that is also true. There will be some money there. Okay. Now I remember. So this minimize inventory holding cost. What I meant by that is it might happen that even if you want to minimize the number of visits. Okay, that's not explicitly mentioned there, but you might want to minimize the number of visits a vehicle is making to an ATM, so overall the total number of visits because of security reasons, etc. And also every time you visit that refill, whether you are loading 5 lakhs cash or 1 lakh cash, it will take some fixed time, so you want to reduce the number of visits plus for security reasons. So it might happen that a vehicle, an ATM has a requirement of 1 lakh, but you actually deposit 1.5 lakhs. Otherwise, I mean, what I mean is, let's say the ATM has a requirement of 50K every day. So objective is one way to do that is every day you send a vehicle and deposit 50K. Another way you can do that is you send one vehicle, you send a vehicle on day one and you deposit 1.5 lakhs. So then 3 days you don't have to send cash. You don't have to refill for that ATM. Again, you might ask, I can deposit 5 lakhs also, but then I don't want to keep so much cash lying idle for 10 days. So again, that is a trade-off. So whether you are sent trade-off between number of visits and the extra cash that is lying idle. So that's what I mean. Yeah, but
There must be an ATM capacity.
yeah, of course, you cannot deposit more than the ATM capacity. So let's say my ATM capacity is 5 lakhs. So you can deposit 5 lakhs also, right? One day for day one, you can go and deposit 5 lakhs. Then for 10 days, you don't have to visit. 9 days, you don't have to visit the ATM. Next 9 days. But that's not a good idea because then so much cash is lying idle. So maybe you can deposit 1.5 lakhs. Then 3 days you have to visit.
Will there also be a constraint on the vehicle capacity?
Yeah,
Because
vehicle
the-
capacity also is a constraint.
Because
Yes.
the vehicle is visiting the bank only once.
Yes.
So then the entire cash, whatever is there, that will be in the vehicle,
Hmm.
whatever it can hold.
Hmm.
So then you can't just put extra cash to every ATM whichever you are visiting because the vehicle itself has a constraint for total cash.
Yeah, that also you have to respect. So let's say that constraint, that capacity is let's say 10 lakhs.
That's also a hard constraint.
Yes, of course. And again, yeah, so it's so you cannot exceed the capacity, both ATM capacity and vehicle capacity, but you have to balance between depositing extra cash and reducing number of visits to number of vehicle visits.
So you also want to maximize the number of ATMs visited by a particular vehicle.
No, not really. That is not an objective, right? Because that will be that will lead to security. So the 20 ATMs I said that's not necessary that you have to visit 20 ATMs. So that's just our view.
You should visit more ATMs because otherwise the what will happen? I mean,
Yeah, if you
there was
visit
an
more ATMs, you will be not depositing extra cash, but then you'll be unnecessarily visiting too many times. So it's balancing between. So that can be a security issue.
how do I visit too many times? Because there are so many ATMs and I have put some money into the first ATM. Only then would I visit the other ATM. And
Mhm.
once my entire vehicle's cash is over, I go back.
Mhm.
So then I won't be visiting extra times.
Yeah, but what you said is you want to maximize the number of visits,
No,
number
I
of
want to
ATMs.
maximize the number of ATMs visited by particular vehicle.
Yes. No, you don't want to max. You could also be see. I have some cash. Let's say my vehicle is carrying 10 lakhs cash. Now, whether I go to 10 ATMs and deposit 1 lakh in each ATM, I mean, let's assume for now simplicity that all the ATMs are equal to one. Whether I go to 10 ATMs and deposit 1 lakh in every ATM, or whether I go to 20 ATMs and deposit 50,000 in each ATM, that is as the model has to decide.
Yeah. The model should decide which one should the model decide. The 1 lakh one or 50K?
Again, that depends. So that's a trade-off. So probably 1 lakh one because in
Yeah,
that.
because it is between lesser number.
Yeah, because then again tomorrow maybe those ATMs, some of those ATMs do not be
Hmm. What I'm saying is that you should put the maximum amount of cash, the demand should be met for a particular ATM,
mm-hmm.
and then you should maximize the ATMs which you are using, is what I'm saying. Until you exhaust all your cash of a
Yes,
particular ATM.
yes. So demand should be met. That is for
Demand should
sure.
be met, and once the demand is met, then that amount of money is collected out of the vehicles
Mhm.
inventory.
Yeah.
And then you, in the similar manner, visit every ATM, and then that one you should.
Yeah, but again, the point is, if when you are meeting the demand of certain ATMs, you need to decide which ATMs demand you want to meet. Do you want to meet more than the demand for a smaller number of ATMs, or you want to meet lesser demand for lesser demand for more ATMs? So that is what the model will help you decide. But yeah, if a vehicle is going to an ATM, let's say it's going to 5 ATMs, it has to meet the demand for at those 5 ATMs. Over and above that, whatever and Okay, now whether we go to whether we go to 5 ATMs or 3 ATMs, 10 ATMs, that again can be.
Used by one vehicle on a particular day.
Yes, only
And
one.
on that particular day, no other vehicle is used in that same day.
Yes.
So therefore, the demand should be met only.
Yes. So if
You
a
can
vehicle
either
is
put
visiting,
extra, or you can put exactly the
you
number.
can, no, that's what I say. You can put extra. You can put extra. So that's so. Let's say if my ATM has 50,000 demand for each day, let's say for the next 7 days, then I can put 50. I can send a vehicle every day, 7 days, and refill 50K. Or I can send a vehicle on day one and put 1.5 lakhs. The next 3 days I don't have to visit. Then again on the fourth day I have to send 1.5 lakhs. That can be another. So that is the advantage, that we will be reducing the number of visits. But the drawback is you will be holding more in cash inventory. So that's what the model which should. But again, instead of 50K, you should not put like 5 lakhs. You should not put 10 days inventory, because one is you're holding onto more inventory in the ATM, plus that is a security issue. So that the model has to be set. Again, there will be a limit on that. So if it is, instead of, you cannot store, let's say, more than 2x of your demand. Like, I mean, or let's say 4x of your demand. So if your demand, I mean, you cannot store. So we call that days of inventory in actual inventory management. So let's say if your demand is 50, 60, 70, 80, then again 70. Then if I have 110, 260 inventory, then I will say that I have 4 DOI. DOI meaning days of inventory. So whatever inventory I have, that can satisfy the first 4 days requirement. Similarly, if this is weeks, if this is instead of days, if it is weeks, and if I have this much inventory, then I will call it WOI. So probably, yeah, I'll speak about it in the next lecture. So that is called weeks of inventory.
So then this strategy is better. Then what is stopping us, for example? So if suppose 50K is a demand
Mhm.
for a ATM, the ATMs in a particular week, it won't fluctuate much. So for instance, suppose
I would, yeah, it will fluctuate on weekends, it will be higher.
Yeah.
Friday, yeah. Okay.
let's say 50K for 4 days.
Mhm.
So in one day you don't want to put more than 200K cash.
2 lakhs.
So why not put 200K
I can put,
for every vehicle? You should do that.
but then you may not have that much cash, right? The bank may not have that much cash.
The bank may not.
Yeah, I mean, it doesn't want to put. So what you're saying is, for every ATM, it will put more cash, but 4x more cash than its demand, right?
Yeah, but the demand has to be met in the next 4 days.
But
that you anyway.
you are sending money 3 days ahead of time, so that's a lot of money. I mean, just imagine this is in crores. We're talking about.
Sure, but I mean that's what you said. If 4K is what 4 times is what is allowed. You cannot.
That is
put
there.
more
So
than 4.
right. So what we're doing in this case is, for one ATM, we are keeping 4 days cash. But again, for the other 3 days, and for the other ATMs, we are not. It is already running from the previous day's inventory. So we are balancing that in the other ATMs. And
Yes.
that way, we are balancing that in the other. But if for every ATM, if you keep 4x cash, then we'll first of all, we might run out of cash and it will not happen. Sorry, it's a trade-off. So sorry, you're asking.
So that residual amount of money that is left with each ATM after the first day, like
After any day, yeah.
after any day, like how do we incorporate in that next days? Like it's a dynamical thing, right? Like
Yeah. So that we discussed yesterday. So this is the. If anyone can help with that equation.
MOI.
Yeah. Like tell me that equation. So we discussed. We are not there. You got it right.
yeah,
So that inventory balance constraint we can write.
okay.
Yeah, actually, I didn't realize that for that constraint, you need to keep. If you want to do that way, then you need to maintain. You need to run one model for 7 days. And coming to any other questions around this? So coming to what you're saying, like if I have time, so I'll wait for 4 hours. So these days, everyone, including users, are also very fanatic about fast results. So one of our models takes 1.5 minutes. So even for 1.5 minutes, they don't want to, it will, so it doesn't, some models it will show, right? I mean, some applications you have seen that it will show it is running or something like that. So they do not want to wait for 1.5 minutes also. So what they want to see is, I mean, what happens is we don't send a notification once the model runs. So user needs to come back to that page and see if it has run. So what they want to know is once it has run, they should get a email notification saying that the model run is complete. So they don't want to. No one wants to waste time these days. Okay.
It's not about wasting time. You don't have a better option. That's the point.
Yeah, but
If you have a better option, if you can limit it in 2 hours, then why not? But
Mhm.
you don't have a better option.
Yeah,
Then
but-
you should have a trade-off then.
Right. But generally, we don't prefer that long solution unless it is really important. So, I mean, unless it is especially for these kind of models where you need to take a decision every day. So, for models where it is less frequent, you need to decide like facility location problem. That kind of models it is fine, but these kind of models where you need to decide every day, because after your model runs, it's not just that you need to take some insights, or user might want to make some manual changes to the model's decision. So for that, they don't want to waste that much time. Okay, any questions on this?
For how many days we are running this model?
That you tell me. You can run for 1 day. I think maybe for 7 days you can run. Next 7 days. It doesn't matter. I mean, from modeling perspective, it is all same. You can assume that you're running for the next 7 days. So then your inventory balance constraint also has to be there, and this third bullet point also you can include in your model. So this is more complex than the first one, or less complex, equally complex, or can't say
Little
as
more.
of now. Huh?
Little more.
Yeah, that's more important.
Like as you saw, I had forgotten some of the smaller points as I was speaking to you, because I had discussed this the previous batch last year, so I had forgotten some of the smaller points, final points. So it came to mind. So okay, there are some changes which I need to make here, like on denomination. So I'll make those changes and I'll put that in Moodle. Then again, uh, you can submit it before your mid sem. So your mid sem starts from
Okay.
third is a Monday. Third.
Third.
Yeah. So before your mid sem, you can submit anytime, second March. And then because mid sem you'll have another 3 hour exam that will be much lighter. Lighter questions, so that will, yeah, anyways, that you have to complete in 3 hours. And you can submit like the previous assignment. And one thing, please, whenever you're writing a constraint, please please describe what the constraint does. Don't just put for variables or constraints. I will not understand. And apart from that, I think the rest of the structure was good. Okay, so this one we already discussed. Okay. Now some quick questions. So is this formulation correct? Or is this kind of constraint possible? So you have only slack and surplus.
What is even meant by it? Because slack and surplus are associated with a particular variable.
Yeah.
If you assume slack and surplus to be some variables, then maybe it's correct.
Yeah, right. So you cannot have this kind of a this kind of a constraint, because slack and surplus has to be associated with a variable. Okay, this is fine. This one we discussed yesterday. So this one. Okay, so the other point is probably we'll discuss it later. This one we discussed. Yeah, so this is another concept. So we have seen the fair share allocation. So we have gone through that extensively. Now what happens is sometimes you might have a scenario where if let's say you have 10 products and 5 products have a pretty high demand, let's say more than 1,000 units, and or let's say 6 products have very high demand, more than 1,000 units, and for 4 products the demand is very less, like let's say 10 around in double digits, right? So you don't want to do the fair share allocation for all of them. So maybe for the products which are more than 1,000, which have a demand more than 1,000, you want to do a fair share allocation. And if it is a small number, you don't want to, you want to finish it off. So you need to prioritize allocation for the low demand product. So this is essentially what that constraints, what this constraint says. So okay, can anyone spell out this formulation for me? This is in Python. This is, but yeah, you can tell me what this two set of constraints does. What does this KO do, or what kind of variable is KO? So volume O is a parameter. Volume O is the demand of the product O. Yeah, the M you can ignore. I mean, just imagine that instead of XMO, just imagine it is just XO, and volume X is a is a variable. X is a continuous variable, and yeah. So can anyone tell me what this variable? It's written in the comment, but yeah, still you can tell me what this set of constraints is doing. So you can ignore that M in M. That M index you can ignore.
So if K becomes 0, that means XO will be greater than the volume. That means the demand has been met.
X will be greater than K is 0. Oh, okay, for now you can just focus on the first constraint. Maybe you can leave the second constraint. Just focus on first constraint.
What is K?
That you have to tell me. What is K? What type of variable is K?
Because K is an array here.
No, K is a variable. Yeah, K is a decision variable.
K of
K
O
and
means what?
oh, that is it's basically like how we write K bracket circular brackets O like that. So in Python we will write it in this way.
Yeah, it's an array.
Yeah, it's an array. Yeah, it's an array, but it's basically like K sigma subscript O. The index of K is O. So O is a product. And what does the first constraint do?
First, the KO is equal to 0.
Hmm.
So that we have total volume minus x less than equal to 0, and the second is greater than equal to 0. That will imply like produced volume equals to total volume, so it's minus min.
Okay, and K equal to 1?
In that means like the demand is not met and volume is greater than what is produced by at least 1. Because second constraint has greater than equals to 1. At least 1 more.
Okay. So if I want to reduce, if I want to minimize the number of products with unmet demand, the option 2 I've written here. So what I need to do apart from this? So I want to go for option 2, minimizing number of products with unmet demand. So unmet demand, as you said, is volume O minus summation of XO, right? I am basically not summation, but volume O minus XO. Right, that is unmet demand. So in order to minimize the number of products, I can just minimize that KO. So basically, KO is telling me whether I am able to. If it is 1, then that means I am not able to meet the demand for product O. If it is 0, I am able to meet the demand, right? Correct. So if I minimize KO, then I will be minimizing the number of products with unmet demand, which is what I want.
Here we are doing like it's discretized, like otherwise like the difference could be some not like integers, it's not
Sorry.
like we also doing like it's not something like say 10.5 people or something because if volume is continuous something x is all of it continuous, then the difference might be less than one. So
X is also continuous. Is that your question?
like, it's possible that like okay.
X is continuous. Yes. I mean, volume and X are both continuous. Okay, so this is what I was telling in the morning today. So when the user, like in this case, we discussed assignment and I gave you some lot of constraints, a lot of rules. So you have to tell me, you have to decide whether these are already covered in the model by some other constraint, or it could be outside the project scope. That means, for example, in the assignment we just discussed, vehicle routing is outside the project scope, model scope, or it cannot be handled by modeling. User should manually handle this. So there can be certain scenarios like that, and could be that there is some rule which is too complex to be straight away included in the model, or it could be that it is one of the constraints is conflicting with some other constraints, so you need to clarify with the user which one they want to do. For example, in the previous assignment, the sports one, we had discussed about the home away but versus fair share allocation across zones. So if it is home away concept, then we cannot have fair share allocation across zones. So that again, all of you discussed, asked me, right? So that you need to clarify. Or it might happen that users might want to model both, but they want to enable only one of the constraints. So in that case, it can be configurable. And sometimes, yeah, and if you want to include it in the model, then you have to decide whether you want to include that as constraint or you want to do that in pre-processing. So, for example, in the previous assignment, the rain thing was we handle that in pre-processing. Okay, and if it is too complex, then you have to either simplify the requirement. For example, in the ATM problem that we just discussed, so if since we are not doing a vehicle routing, if we try to include the time aspect and all that, it will become very complex. So instead of that, we're trying to simplify by assuming that every distance between every ATMs is equidistant, like 30 minutes. So we have to make good assumptions in that. Now, how I came up with 30 minutes, that is I put in the sentence, but you have to come up with that, whether it should be 30 minutes or whether it should be 45 minutes. That assumption you have to come up with. And again, the 30 minutes can vary from day to day. So on weekdays it might be higher, on weekends it might be lower. Or you need to recon. Sometimes some requirements have to be done, and you cannot simplify that. So in that case, you need to completely scrap your model and come up with a new one, or you have to ignore the requirement. Ignore meaning if you tell the user that this cannot be done in the models, you have to do it outside the model. Yeah, so and this one cannot be handled by modeling. User should manually handle this. So there can be some after the model solution, users sometimes make some changes manually due to some operational constraints. For example, they might want a particular driver on a particular route. Or sometimes if there is some road condition, so maybe the particular road is blocked, so the vehicle cannot take that route. So those are certain uncertain things which need to be handled manually. Okay, and in the model we get different kinds of issues. One is explainability issues, like we were discussing yesterday, whether if we are not able to meet the demand, then is it due to low inventory, low capacity? So that is explainability issue. Then the next one is infeasibility issue. Infeasibility already know, and long time to converge, meaning what you just said, that sometimes models might take 4-5 hours. And sometimes for big models it might run out of memory, and again that you can resolve that issue by reducing your problem size. and sometimes the code crashes. Basically, like we are discussing about the end of horizon constraint yesterday. So if you have that kind of that is one example. So you can have that kind of scenario. So the code will crash. It is not a mathematical issue, but rather a programming issue. So you have not handled a particular array as expected. So out of these issues, which one do you think, or which ones do you think are higher priority issue, or most important to, most urgent to resolve out of these 5 issues?
Code crashes.
Of course, code crashes. Yes. Next.
Invisible.
Next. Next. Well, then that's it. These are the most important issues. So we will be looking at these one by one. So today I will try to cover infeasibility, and in future lectures will cover the long time to converge and explainability. So let's look at infeasibility. Um, so managing and detecting infeasibility. So one is what is the difference between managing and detecting?
Things to like know that you have something invisible. Managing is after you detect it, you provide measures to
Yes.
control it.
Control in the sense remove that.
Remove it.
Yeah. So okay. So what we do in how do we? So let's say I think managing, not managing. Yeah. So coming to detecting now. So sorry, what did you say? Managing is finding after or before?
Managing is after.
After. Yeah, actually, then probably this. Yeah, that is true. But this the word detecting here I should remove then, because this detecting is actually after we build the model. So I'll remove the word detecting here. Anyway, different constraints, and after you run the model, it says you find the model, the solver says that it is infeasible. So how will you find out which constraints are how many constraints? Yeah, which constraints are conflicting? Yeah, this is a question I asked the interview I took last week, because I mean, of course, the solver will do now in this case, but let's say you don't have a solver, you have to do it yourself. So how would you do it?
Can we remove like one by one the constraint?
No, you have 10,000 constraints. You cannot remove one by one, and maybe out of them 100 are conflicting. So I think.
How many variables are
It doesn't matter. But yeah, let's say you have 1,000 variables.
you should find for a particular linear combination of the variables where it is appearing in more than one constraint.
Let's say it appears.
So if it appears in more than one constraint, then only there we should check which are the conflicting ones and we should resolve it.
But you have a lot of variables, right? How will you check? You will check for each variable. I mean, I didn't get your concept. So you
My
have.
concept is like you have you said like we have 10,000. So constraints are made up of some linear combination of
Yes. Yes.
variables. So we should find where a particular linear combination is reoccurring.
No, it may be. Oh, what you're saying is.
So for example, take C1 first constraint and then find. So C1 would be made up of one.
But it
linear
may be
combination.
that constraint, that linear combination is not reappearing. So what you're saying is if you have 4x plus 5y less than equal to 7 and 4x plus 5y greater than equal to 10,
I will find 4x.
but you may not have that, you may not have 4x plus 5y anywhere at all, or in another constant you might have 4x plus 5y plus something.
Yeah. And wherever it appears, this combination.
No, it may not appear itself.
It may not appear, okay.
So okay, we'll come to how to find out manually later, but now we'll go through how the solver finds it. So solver has this, every solver has this thing called IIS. IIS is irreducible infeasible set. So out of those 10,000 constraints, it will give you a set of, let's say, 100 constraints, which will be a minimal conflicting set. Meaning, even if you remove one constraint from that set of 100 constraints, with IIS of 100 constraints, you will be able to, that solution will be feasible. So that is, so as you see the first time, so it is a minimal set of constraints and variable bounds, which is infeasible, but becomes feasible if any constraint or bound in it is removed. So yeah, so and the complex part is it might happen that a model has several infeasibilities. So after you resolve the first IIS issue, again if you run, you might have again run into infeasibility. So again you have to resolve. Or it might happen that there was only one infeasibility. So you have to keep resolving the infeasibilities one after the other till all the infeasibilities are resolved. So let's say you have
IIS, for example, you said that if you remove even one constraint, then that thing becomes feasible.
Yeah. So let's say your problem
becomes feasible, then what's the point in running it again?
So okay, so there might be different sets of infeasibilities. So let's say so let's say this is your universe of 10,000 constraints. Right? Now you have one set of one IIS which is like this, IIS1. It has, let's say, 100 constraints. Now it might happen that there is another IIS here which is let's say 500 constraints. So once you resolve this, you'll get this one. Or it might be that it has only one IIS. So once you resolve this, you will the problem is feasible. And what the optimizer will do is it will
suppose you run it once, then you will get both of these sets, right?
No. What it will do is it will not show. So there is a code. It will show. It will show you all the. I mean, it will tell you that there are like 20 IISs like this. Let's say, okay, let's say there are 3 IIS, but it will show you only the first one. So, but yeah, you can also print all the IIS at the same time, and then you can resolve it in one shot.
Yeah.
That also will do. So because they are not independent of they are not dependent on each other. So yes, that also you can do. Now what happens is this resolving this finding this IIS is sometimes very complex especially for complex bigger problems. So in what the optimizer will do is like finding the optimal solution. It has a time limit like that. You can put a time. You can put a time limit on the time it will take, maximum time you can take to detect the IIS, find out IIS, and it will within. So let's say you put a time limit of 2, like you see the highlighted part here. So I've set a time limit of 2 seconds. So in the 2 seconds, it will try to find out the smallest IIS it can. Meaning, let's say it will try to reduce 10K. It will try to in 2 seconds. It will from 10K. So let's say this is not there. It has only this one. It will reduce from 10K to let's say IIS having 300 constraints. And if you allow it 10 seconds, it might be able to get to this 100 constraints.
So, one more question is like, I only need one value of the IIS. That's enough for me.
No, one IIS is like the complete set of constraints.
Exactly. So, when I remove one, I will make it feasible. I just need one.
No, that is a problem. So the problem there is, so certain constraints. Now, how do you cannot remove the constraints altogether? I mean, so when you say remove the constraints, what you can do 2 things. Either you can remove the constraint, or you can change the RHS. either increase or decrease the RHS. Right? These are the two actions you can take. Now, let's say there is a conflict between the mass balance constraint and the capacity. Right? Mass balance constraint you cannot remove. That's a mathematical constraint. So that means you have to increase the capacity.
Okay.
Right? So that's why you cannot randomly the solver
So we
cannot
have to
decide
have the
randomly.
entire set.
Right?
So once we get the entire set,
Yeah, then you
manually-
have to manually decide which to remove. So that decision, so that is something which cannot be automated. Solver has to decide. You have to decide which of these. Or let's say it is a conflict between capacity and demand. Now, capacity you cannot generally increase, but demand you can decrease, right? Or you can make it as soft constraint that way. So this is another thing. So once
although many of those can be still fed in the model. Many of those things, like for example, that mass balance is a hard constraint that can't be used. So we can feed it in the model. So it's a hard constraint. Then whatever you said, the capacity and demand. Capacity is fixed. The demand we can, but there would be many such things.
yes.
On a model, it would be difficult to build up a model of that. It's better to do it manually.
Yes. Yeah, but sometimes what happens is the IIS itself might have 1,000 constraints. So especially in problems where it is because of tolerance issues like integer problems, it sometimes has thousands. There it is very difficult. So I like once you work on the problem, particular problem, it's more about strategizing. So how you will resolve it in minimum time. So you have to once you get a practice, you'll be able to do for that problem. So you know that this set of constraints generally creates a problem. So you will directly go to that set of constraints instead of trying to figure out the entire IIS. Yeah, so again, this option you have, so based on your requirement, I mean, 10 seconds is okay, but let's see if it takes, you can wait obviously for 8 seconds more, but let's see if it takes 10 minutes to reduce to 50 constraints. So again, it's a trade-off you have to make, whether you want to wait for 10 minutes to get 50 constraints or you want to get a 6 times bigger IIS in 2 seconds. Yeah, and again, it stops when it runs max time. Yeah, so this 300 this 50 constraints will be a subset of 300 constraints. Okay, I think this is about that slide. So what are the steps to detect and remove infeasibility? So once you have infeasible model, yeah, and by the way, just wanted to show you this line was doing it here. Sure, sorry. Reset that. Hello. I'm here to pore kitchen classes. So this one, if you see, we try to make it a bit bigger. So if you see these two lines, so we were earlier seeing this. So this one, what we are saying here is, all of you can see this, right? So IIS all, meaning you want the solver to come up with all the IIS, and then the next line is IIS write 1, then the directory, and 0, I don't know what the 0 does, but this 1 is essentially, it means that out of all the IISs generated, you want to write the first one only. So this is the sequence, this is the syntax to get the IIS printed. Okay, now I'll show you one real actual IIS. So this is so if you see, there is one small, and it's not big also. This is a very little bigger IIS, I should call it. So the one on the left hand side is, it says that simple IIS with two variables. It basically says that x greater than equal to something and x less than equal to 0, which is conflicting. While on the right hand side, you have a bigger IIS with maybe like 20, 30 constraints. So this is one example. Now, what are the steps to be followed to remove infeasibility based on IIS? So once you see that the model is infeasible, then you will ask it to run the IIS as you saw in the code just now, and then you will manually check the IIS to understand the reason for infeasibility. Then you will make the necessary changes so that either you have to make or the user has to make, meaning if it's a model, it could be a model issue. Like you might want to make it a soft constraint instead of hard, or there might be some other model bug. So that you have to do, or it could be the user has to change some input data. So maybe the user had put some constraint which cannot be satisfied, put some value which cannot be satisfied for, let's say, capacity or demand. So then that value needs to be changed either by you or the modeler. I mean, either by you or the user, and then you might you have to rerun the model again, and it might be next time it might be feasible or unfeasible. If it is feasible, it's good. If it's infeasible, you again need to repeat these steps. So this one we just saw, and again this one as I was showing you. So this is this was an example where you have this is from the solver log. These screenshots are from the solver log. And if you see here, there are, in this case, the solver, in this case, there were 20 IIS, and I put screenshots of 1, 2, and 16 to 20, 16, 17, 18, 19, 20. 3 to 15, I'm not sure. So anyone can tell me what are these? So here it says UP, LE, GE, LO. What are these? What is the, what
Less
are
than
these?
equal to
And UP? Right, it is on the same line as you, as LE less than equal to greater than equal to, just think of it.
Oh, upper bound.
Yes, upper bound and what? Yeah, there is no LO, right?
No, there is a low, I think.
There is LO, there is lower bound. So LE, GE, you will have for, and there is no EQ. EQ is equal to, but there is no equality constraint here, I guess. So essentially, so now it says here row and column. So what is row and what is column?
Lowest for the constraints at the bottom.
Yeah. So that's right. So that's why columns is column is variable. So in variable only variable you have UP and L, upper bound, lower bounds. And in constraints, as you saw, you have those R starting with R in the LP file. So these are your constraints. So you can the constraints are less than equal to or greater than equal to, right? Okay. And now looking at this, looking at the previous CLP. So this is called, so what you saw in the morning, that was called LP file. So the file extension is .lp. So this is called a CLP. So CLP is .clp. So CLP. So CLP means conflict linear programming. And this is one slide which shows how different IIS can overlap. So if you can see here, there are different kinds of scenarios. So you can have dependence among the IIS, or they can be completely independent, or you can have only one IIS. Yeah, and in general, greater the magnitude of violations, more will be the number of IIS.
Does it make a difference to analyze what kind of overlaps are there in different kinds of IIS?
No. You have to just resolve the conflicts one after the other.
Probably it would be better if we try to suppose
And what
there
are
are overlapping terms.
Right. That's what I was coming to. So if it's overlapping, then if you pick something which is the center, then all the IIS will get resolved automatically. in general, so let's say if you have, so let's say you have a constraint x less than equal to 10. Okay, x plus y plus z less than equal to 10, and you have x plus y plus z less than equal to 7. Which one will give you, and let's say this is conflicting with some other constraint. So which one will give you, which of these two constraints will give you an IIS of bigger size?
Less than equal to 7 because it's a tighter constraint.
Yes, right. Okay. And how to avoid infeasibility? I think this one you already know. So by adding slack surplus variables. But what is there any drawback of adding too many slack surplus variables? Or maybe I don't remember whether I discussed this earlier. But yeah, if you have discussed, then it's an easier question.
Too many slacks and surplus means too many soft constraints.
Mhm. That is good, right? Because I'm removing, ensuring that none of my constraints, nothing is infeasible.
What if the constraint is inherently hard? Doesn't make sense to include.
That is there, but let's say everything is soft. Yeah, like for example, you had that every team will play against the other team. You have made it soft. So, but let's say you are not. Let's say you don't have any constraint like that. Let's say everything is soft, and you have made everything, written everything as a soft constraint. Then what is the issue?
I mean, what is there to solve? Everything will be in somewhere slack or something.
You are actually increasing the solution space, right? So it's good. It will be a more optimal solution. Otherwise, if everything is tight, it will be less optimal.
Mentally,
Hmm?
mentally
Runtime will increase or decrease.
increase
Why?
because there are too many different. We have created more variables.
No, let's say all the variables, slack surplus variables are continuous.
But still, you need to optimize all those slack and surplus.
Yeah. Okay. So the answer is yeah. I mean, it will increase with the runtime may increase with when you add slack surplus variables, but it is not because you're adding more variables, but because you are making the solution much less tight than it was before. If you add slack surplus everywhere, so it gets more solution space. So also that makes it much less tight. So that is the reason. Mm, okay. Yeah, and this is one example where if you have multiple sequential solves, then okay. So we discussed in yesterday's lecture that we are solving first the linear relaxation, then we are adding the batching constraints in the next subsolve. So let's say in the first subsolve, you get a solution of 3.92 whatever, and then you might be doing some rounding off, or the computer might be doing some rounding off, and in the next subsolve, if you have a constraint which says x less than capacity, but in capacity you have already hit the capacity limit in the first subsolve, and since you have done rounding off, it has increased slightly. You have increased the value slightly, subsolve. So sometimes this is a problem which happens when you have a lot of multiple subsolves on this kind of tolerance issues. So it is better. Sometimes we need to add some slight tolerance to avoid such issues. Another solution can be to reduce physics. So feasibility tolerance, we'll see that in another lecture. So there are different kinds of tolerances. I think this is fine. Okay, I think we'll stop here then. So, so we'll meet again next Saturday for the online class. How is it going so far? Are you happy with the course contents? Is it useful? It's boring, sleepy, better than the other courses, worse than the other courses?
It's
I-
different.
I mean, different because I've see this one I wrote completely on my own. Like it's based completely on my experience. Some slides you have seen, I have just written the header. There is no contents. So just to explain the idea.
Much more interactive,
Okay.
not so theory heavy.
Do you want me to focus on any particular concept?
Problem is we don't know.
Yeah, that is the problem. Yeah, I know. That's why I am deciding. But I think more assignments will be helpful because you will get you'll think more broadly about the problem, and that will be helpful not just for that assignment or that course, but overall. Since all of you will be joining industry, you need to have a broader perspective. You need to ask questions to the business, what regarding their operating procedures. So that kind of thinking is very much required. Because in India, I've seen that generally students will just do their projects. So if you ask them slightly beyond the project, they are not able to answer. So I think that is one aspect where we lag behind. So okay. So offline class again, I'll probably come sometime in end of March, towards end of March.